For this podcast, please have note page number 23 in front of you. The fourth and fifth examples of organic reactions that we're going to talk about in this vodcast are going to be esterification and saponification. Let's start with esterification. Okay, now with esterification, we have an ester. We talked about esters in the middle of this particular unit. An ester is created putting an alcohol and an acid together by the means of dehydration polymerization. In other words, what's going to happen is you're going to have the production of an ester and a water. Let's take a look at the generic formula for esterification first. All right, so we know that we have an OH present and some sort of hydronium present. All right, so we've got an organic acid that's going to combine with an alcohol. And what's going to be produced is the ester and water itself, a molecule of water. All right. So if we were to take an organic acid, let's start with CH3COOH, and we'll combine that with CH3OH, and what's going to be produced is our ester, CH3COOCH3, and then of course water. All right, let's show you how this happens structurally. You're going to have to, on a Regents exam, you won't have to draw anything like this. Won't draw in the Regents exam, but you're certainly going to have to be able to predict what the products are going to be. All right, which shouldn't be all that challenging because you know with esterification you are making an ester and you're going to produce water as a side product as well. All right, so let's draw out structurally what this chemical reaction would look like. So here's our CH3. We'll start with this here. Double bond of oxygen. Produces our organic acid. Here's the OH. Combined with that is going to be our alcohol, CH3, CH2, and the OH. Right. This is a reaction that can go in either direction. Right. So it is at equilibrium. And what's going to be produced is a CH3. There's a carbon. There's a double bond of oxygen. Off the other carbon is going to be the oxygen. Here's the new piece, which we'll talk about. Here's your CH2. Here's your branch, CH3. And then, of course, you're going to have your water molecule present. Okay. So what's happened in this chemical reaction is that this H off of our first reactant and this OH off of our second reactant, what they're going to do is they are going to chemically combine together to produce the water, one of our two products. Right, so you can see how the H and the OH will come together to produce the water. Now, the meat of this particular esterification reaction is now we've got an opening here, right? Because once the hydrogen has left, I don't want to erase too much here. Right, the hydrogen's gone. And we've also lost the OH, which is now branched off to make the water. So what's going to happen, and you see this on the product side, is that this CH3, CH2 is going to attach itself to the opening here of where the oxygen is to give us this product right here. All right, so what's produced is this ester right here. You can see how it's branched together with the remaining piece of the alcohol and the opening of where the oxygen is, right? So this is esterification. Now the second reaction is called saponification. And if you look at the term saponification, you might be able to somewhat come up with the term of soap. If you kind of rearrange the letters here a little bit, you can see that this is the whole process of making soap. The ester is always going to be found on the left side, right? So you're always going to have an ester over here. We'll put it in this first box, right? So your ester is going to be located here. Let's go ahead and write it in. The ester is going to be added to. The ester reacts with an inorganic base, right? So our base is going to be here. And what's going to be produced is an alcohol. Glycerol is the alcohol that's typically produced. Right, so our alcohol is going to go here. And the final product is what we're really concerned with here, is we are now also going to have a soap is going to be produced, which gives us saponification. So here's your soap. From a fat and from the strong base. All right, so let's take a look at it structurally and kind of walk through this slowly and carefully to see how the production of soap is actually developed. All right, so here we have our triglycerol. Right, this is our enormous, this is our huge, huge, very strong ester. Right, this is something you're just going to have to identify. You won't have to draw anything like this either. What happens with this whole process is that this piece, very large piece right here, take the time to highlight this in, this is going to break off. This huge, enormous piece is going to break off. I'll show you where it goes, which is going to leave behind the CH2, the CH, and the CH2 itself. All right, so this is going to be left behind here. Okay, and what's going to happen here with the base is that the OH, three of them, is going to replace this large mess here. All right, and this big piece here of the triglycerol is going to be located with the addition of the three sodiums that are going to be attached to it as well. So the big blue piece is branched off and the OHs are added to the CH2, the CH, and the CH2. And you can see that that first product is right here. All right, this is your glycerol. This is your alcohol that's produced. Now the rest of it, this big enormous piece here, and the three NAs, this is your soap that's produced. And that is located right here. Right? Things have been combined together to make it look a little bit simpler, if you will. You can see all the carbons and the hydrogens have been combined together. You've got your three double bonds of oxygen, right? Your coefficient of 3 tells you that. CH3, and of course, here's your sodium that's located here as well. Right? This is the soap that's produced. Right? So you're breaking off a huge piece of this triglycerol. It's being replaced with the three OHs. That's this right here. The huge piece of triglycerol is now being combined here chemically, along with the three NAs that have broken off of the very small base on the reactant side. All right, so this looks and is a very complicated chemical reaction. Okay, so when you're seeing these large chained, very huge, enormous esters involved with a base, you know that you're leading along the path of defining and showing a saponification chemical reaction, which is the production of soap.